About 4.6 billion years ago, the solar system as we know it began to take shape from a vast cloud of gas and dust, known as the solar nebula. This enormous cloud, mostly composed of hydrogen and helium, was a remnant of earlier generations of stars that had lived and died, contributing heavier elements to the mix through supernova explosions. These heavier elements included oxygen, carbon, iron, and silicon, materials that would eventually form planets, moons, and other bodies in our solar system. The solar nebula remained relatively stable for millions of years until it experienced a disturbance, possibly from a nearby supernova explosion. This event sent shockwaves through the nebula, causing it to collapse under its gravity. As the cloud contracted, it began to spin faster due to the conservation of angular momentum, much like a figure skater pulling in their arms during a spin. This spinning motion flattened the cloud into a rotating disk, with most of the material concentrating at the center. At the center of this disk, the temperature and pressure began to increase dramatically as the material continued to collapse. Eventually, these conditions became extreme enough to initiate nuclear fusion, the process that powers stars. Hydrogen atoms started to fuse into helium, releasing tremendous energy in the form of light and heat. This marked the birth of our Sun, the central star of the solar system. While the Sun formed at the center, the remaining material in the disk began to coalesce into solid particles through a process called accretion. These tiny particles of dust and ice collided and stuck together, gradually forming larger and larger bodies. Over time, these bodies grew into planetesimals, which were several kilometers in diameter. Some of these planetesimals would go on to form the planets, while others became moons, asteroids, and comets. In the inner part of the disk, where temperatures were high, only metals and silicates could solidify, leading to the formation of the rocky planets, Mercury, Venus, Earth, and Mars. These planets are composed primarily of iron, nickel, and silicate minerals. Closer to the Sun, where it was too hot for gases and ices to condense, lighter elements like hydrogen and helium were mostly blown away by the solar wind, leaving behind the solid, rocky cores. In contrast, in the colder, outer regions of the disk, beyond what is known as the frost line, ices could form from water, methane, and ammonia. Here, the planetesimals were able to grow much larger due to the abundance of these ices and gases, eventually forming the gas giants, Jupiter and Saturn. Farther out still, Uranus and Neptune formed as ice giants, consisting mainly of heavier volatile compounds. The gravity of these giant planets also allowed them to capture vast amounts of hydrogen and helium, contributing to their enormous sizes. As the Sun matured, it began to emit a powerful solar wind, which gradually swept away the remaining gas and dust in the disk. This process marked the end of major planet formation, as there was no longer enough material for large bodies to grow. However, smaller remnants of the disk continued to orbit the Sun, forming the asteroid belt between Mars and Jupiter, and the Kuiper belt beyond Neptune, which is home to many icy bodies and dwarf planets, including Pluto. Over millions of years, gravitational interactions between the newly formed planets and leftover planetesimals caused further evolution of the solar system. Some planetesimals were ejected from the solar system entirely, while others were captured as moons or sent on collision courses with planets, leading to the craters we see on the Moon and other planetary surfaces today. The solar system we live in today is a product of billions of years of complex interactions between the Sun, planets, and countless smaller bodies. It's a dynamic system, still evolving, with new discoveries constantly shedding light on its formation and the processes that shaped it. Understanding the solar system's formation not only helps us comprehend our own cosmic neighborhood but also provides insight into the formation of other planetary systems across the universe. The solar system's story is far from over, as scientists continue to explore its farthest reaches and uncover the secrets of its origin. Each new discovery brings us closer to understanding the full history of the solar system and our place within it. Thanks for watching.